So welcome back. In today's video, we are going to continue with the methods of evaluating limits. In this particular case, we are going to look at how to evaluate limits at infinity. So what happens in this case? We first divide the numerator and the denominator by the highest power of x in the denominator. So we have examples here that here we are going to evaluate the limit of this function f of x as x approaches infinity. And you'll notice that this function, it is in fraction form or in rational form. So in the solution, this is what we have. This will be equal to the limit as x approaches infinity. We have our function there, which is 5x cubed minus 1 over 4x cubed minus 2x minus 1, which will be the same as what? So we say that we divide both the numerator and the denominator by the highest power of x in the denominator, which is 3. So meaning that this will be the same as what? 5x cubed minus 1 over x cubed divided by, that is the numerator for you, this will be 4x cubed minus 2x minus 7 divided by x cubed. And this will give us what? The limit as x approaches infinity of 5x cubed divided by x cubed minus 1 over x cubed. All these divided by 4x cubed divided by x cubed minus 2x divided by x cubed minus 7 over x cubed. So you realize that this will cancel in that one. So for this one, it will remain the way it is. You simplify this will go in that one. So by x here we get 1, by x you get x squared. The other will remain the way it is. So that now we shall have the limit as x approaches infinity of 5 minus 1 over x cubed divided by 4 minus 2 over, we are left with an x squared there. The other one, it is minus 7 divided by x cubed. This will be the same as what? So in this particular case, by direct substitution, which is a technique of evaluating limits, it means that we replace x with infinity. So whenever you have x, we replace it with infinity. So this will be equal to 5 minus 1 over infinity, because infinity cubed, you still get infinity, divided by 4 minus 2 over infinity squared, which is just infinity, because when you square infinity, you still get infinity, minus 7 over infinity cubed, you still get infinity. So, but any number that is divided by infinity, you get a 0. So, meaning that this will be the same as what? 5 minus 0, because 1 divided by infinity, you get a 0, over 4 minus 0 minus 0. And of course, 5 minus 0, you get 5. And 4 minus 0 minus 0, you get 4. So, this will be now our limit for this particular problem. That is the limit of 5x cubed minus 1 over 4x cubed minus 2x minus 7 as x approaches infinity is equal to 5 over 4, which is this value here. So the second example, it is evaluate the limit as x approaches infinity of this particular function here, which is x squared plus 3x plus 2 over 2x cubed minus 8. So what will be the solution here? That this limit as x approaches infinity of x squared plus 3x plus 2 divided by 2x cubed minus 8. So once again, we look at the highest power of x in the denominator. And in this particular case, it is 3. So this means that we divide both the numerator and the denominator by x power 3. Now this will give us the limit as x approaches infinity of x squared plus 3x plus 2 over x cubed divided by 2x cubed minus 8 divided by x cubed. So what is going to give us what? Well, this is going to give us the limit as x approaches infinity of x squared over x cubed plus 3x over x cubed plus 2 over x cubed. This is divided by 2x cubed over x cubed minus 8 over x cubed. So of course, this will cancel with that one, that we are left with the next here. This will go with this one, so that we are left with an x squared here. So this is supposed to be x, this is x squared, because it is by x, 1 by x squared. So that one will remain unchanged. But the denominator, this will go with that one, because it is x cubed. This part will remain unchanged. It is going to give us what? The limit as x approaches infinity of, this is supposed to be 1 over x plus 3 over, this will be x squared plus 2 over x cubed divided by, this will be 2 minus 8 over x cubed. 8 over x cubed. So which by direct substitution, it means that you are replacing the values of x with infinity. So this will be 1 over infinity, that is in the numerator, plus 3 divided by infinity, because infinity squared you still get infinity, plus 2 over infinity, because infinity cubed you still get infinity, divided by 2 minus 8 over infinity, because infinity cubed as well, it is equals to infinity. So, but any number that is divided by infinity, you get a 0. So, meaning that this will be 0, that is 1 over infinity will be 0, plus 3 over infinity, which is 0, plus 2 over infinity, which is 0 as well, divided by 2 minus 0. At last, it is going to give us 0 over 2. We know that 0 over 2, you get a 0. So this is to imply that the limit for this particular function as x approaches infinity is equal to 0. In the third example, we are going to evaluate the limit of this function here as x approaches infinity. So what is going to happen here? You notice that the highest power of x in the denominator, it is 2. So meaning that you are going to divide both the numerator and the denominator by x squared. So which is, this would imply that this 3x squared minus x plus 2 over x squared plus 8x minus 1, that is the limit as x approaches infinity, will be equal to the limit as x approaches infinity of, we divide the numerator by x squared, which is as follows, and also the denominator we divide by x squared, supposed to be squared. So which will give us what? It means that each and every term in the numerator is divided by x as well as the denominator. So this will be the limit as x approaches infinity of 3x squared divided by x squared minus x over x squared plus 2 divided by x squared. All these divided by x squared over x squared plus 8 over x squared minus 1 over x squared. So obviously this will cancel with that one. by x1 by x, will be left with x. This one will remain unchanged because it's not common factors. So these will cancel with that one. The others will remain, but this is supposed to be x, sorry, because it is 8x divided by x squared. So by x1 by x, it is supposed to give us x. So which would be equal to the limit as x approaches infinity of 3 divided by x squared, everything there it will be 3, minus, supposed to be 1 over x, plus 2 divided by x squared. That is the numerator for you. For the denominator it will be 1 plus, so it is supposed to be 8 over x minus 1 over x squared. So which by direct substitution, we are going to replace, whenever we have x, we replace it with infinity. So this will be 3 minus 1 over infinity plus 2 divided by infinity, because you know that infinity squared, you still get infinity, over, this will be 1 plus 8 over infinity minus 1 over infinity squared, which is just infinity. And you all know that any number that is divided by infinity, you get a 0. So these will simplify to 3 minus 0 plus 0 is divided by 1 plus 0 minus 0, which will give us 3 minus 0 plus 0, you get a 3, over 1 plus 0 minus 0, you get a 1. Now the final answer will be 3. That is the limit of this particular function as x approaches infinity will be equal to 3. So the next technique of evaluating limits is what we call rationalization. These will be applied whenever we have functions with surds. Whenever we realize that the functions involved have surds in them. So what happens in this particular case, we multiply both the numerator and the denominator by the conjugate of the factor containing the surd. The surd could be in the numerator or the denominator. It could be in the numerator or the denominator. But now, what is this surd? A surd is simply defined as an irrational root of a rational number. So let us go straight to an example whereby in this particular case we have the first one, it is evaluate the limit as x approaches infinity of this particular function that is given here. But this function is under 1, so meaning that your numerator it is in surd form and the denominator is just 1. So the solution, this would be the limit as x approaches infinity of root x squared minus 4x minus x divided by 1. So we have this term and this term in the numerator. So the conjugate of it, what we just need to change is the value that is in between these two terms, from negative to positive. For example, if you are given root a minus root b, so that is our function. So the conjugate of it will be just root a plus root b. And you notice that whenever you multiply root a minus root b times root a minus or plus root b, this is going to give us what? A minus b, which is a rational value. Assuming that this a and b are integers. So the same will apply here. We multiply both the numerator and the denominator by the conjugate. So the conjugate of this, it will be, we just need to change this. We are treating this as a term on its own and this as a term on its own. So meaning that for the numerator we multiply by x squared minus 4x plus x. And what we do to the numerator, we also do to the denominator, which is we multiply by root x minus 4x plus x. So this is going to give us what? This will be the limit as x approaches infinity. So you notice that if you multiply this times this, using this property here, that is a minus b multiplied by a plus b, which is going to give us what? A squared minus b squared. That is the binomial expansion. you realize that the simplified form of this product, it will be the same as what? This will be just x squared minus 4x, then with minus this term squared. That is, whenever you multiply this times this, the answer will be this. So why? Because we are squaring this term and squaring this term. If you square this term, the root sign will disappear. Because we know that whenever you multiply root 2 times root 2, the answer is equals to 2. It's only the root sign that is disappearing. So this is divided by root x squared minus 4x plus x. Why? Because whenever you multiply this by 1, you get the same value. The number that is multiplied by 1, you get the same value. Then we try to simplify the numerator. You realize that x squared minus x squared, you get a 0. And now this would imply that you'll be left with what the limit as x approaches infinity of negative 4x divided by root x squared minus 4x plus x. That is what we have. This will give us what? So what happens at limits at infinity? Limits at infinity, we divide both the numerator and the denominator by the highest power of x. So in this particular case, the highest power of x in the denominator is x, or is 1. Because this square has been affected by the square root. We cannot conclude that the highest power of x is 1 or is 2. So meaning that now the highest power of x is equals to 1. Because even if you take the square root of this x squared, you still get an x, which is 2 power 1. So meaning that here we are going to divide the numerator and the denominator by x. And this will give us what the limit as x approaches infinity of, this will be 4x negative divided by x, or this divided by the square root of x squared minus 4x plus x. So this will cancel with that one, so that we are left with what? The limit as x approaches infinity of negative 4 divided by root x squared minus 4x plus x, all these multiplied by 1 over x. So meaning that this 1 over x, because we are dividing by x here initially, that is here, but this is divided by x. This is just the same as taking this value, which is the denominator, you multiply by 1 over x. So meaning that you can open the brackets, this multiplies everything here. So that we are left with the limit as x approaches infinity of negative 4 divided by, this will be multiplied by this, you get 1 over x root x squared minus 4x plus, this will multiply by this, you get 1. So that is it. So the other thing, it is to simplify this further. That is, you bring this 1 over x under the root sign. For you to be able to bring this under the root sign, you have to square it. That is 1 plus 1, 1 over x, you square it. Then you multiply with what we have under the root sign here. And this is done as follows. That is the limit as x approaches infinity of negative 4 over. So now this would be root 1 over x squared. Because 1 over x squared, you get 1 over x squared. Because when you square 1, you get 1. When you square x, you get x squared, which is what we have here. You multiply by x squared minus 4x. And this you add what? 1 at the end. So you have not changed anything, it's only that you have brought this 1 over x under the root sign. So this will be the same as what? The limit as x approaches infinity of negative 4 divided by the square root. So when you multiply 1 over x squared times x squared, you get 1. And when you multiply 1 over x squared times negative 4x, this is supposed to give us minus 4 over x. Then of course we should add a 1, which is at the end there. That is a simplified form of that particular function. So which by direct substitution, it means that whenever you have x, you replace it with infinity. And this will be negative 4 divided by the square root of 1 minus 4 over infinity. You add 1. So which is going to simplify too. Because whenever you have any number divided by infinity, you get a 0. So this will be negative 4 divided by the square root of 1 minus 0 plus 1. Which is going to give us what? Negative 4 over root 1 plus 1. But the square root of 1, we write it here. The square root of 1, you get 1. So meaning that this will simplify to negative 4 over 1 plus 1, which is equals negative 4 over 2. This is going to give us negative 2. So meaning that this is our limit. So the next example is evaluate the limit as x approaches 9 of this particular function here, which is root x minus 3 over x minus 9. So this is a solution. You can clearly see that the third is in the numerator, not the denominator. And the third is this value, root x. So meaning that this will be the same as what? You need to rationalize this. This means that we multiply both the numerator and the denominator by root x plus 3. That will be the conjugate of this root x minus 3. And what you do to the numerator, you also do to the denominator, which will give us what? Root x plus 3. So once you multiply this times this, that is the numerator, from this property here, a plus b multiplied by a minus b, which is going to give us a squared minus b squared. So this means that you just need to square this and square this. Then you add them together. And this will give us what? The limit as x approaches 9 of x minus 9 divided by now the product of this, which will be just presented as x minus 9 multiplied by root x plus 3. The reason I did not expand this is that I realize that this will be a common factor, that is x minus 9 will be a common factor between the numerator and the denominator. So there is no need of multiplying this times this. So once you reach at that particular step, you can cancel this because you notice that it is common. And what will be left with, it is the limit as x approaches 9 of 1 over root x plus 3. Which will be the same as what? By direct substitution. It means that whenever you have x, you replace it with 9. This will be 1 over the square root of 9 plus 3. And you know that the square root of 9 is 3. So which will give us what? 1 over 3 plus 3, which is going to give us 1 over 6. So in the next example, we are going to evaluate the limit as x approaches infinity of this particular function here. Remember, this is under 1. The whole of it is under 1. So meaning that this is your numerator, this is your denominator. So to evaluate that, this will be presented as follows. You have root x squared minus 2 minus root x squared plus x, which is over 1. So meaning that you have to multiply the numerator and the denominator by the conjugate of the numerator, because that is where the third is. So this conjugate will be x squared minus 2 plus, you can see it is only the sign that is changing from positive or from negative to positive. This is plus x squared plus x. And what you do to the numerator, you also do it to the denominator. The denominator will be x squared minus 2 plus root x squared plus x. then you multiply. So this implies that all these will be the same as what the limit as x approaches infinity from this property here, which is a minus b multiplied by a plus b, which is giving us a squared minus b squared. So this will give us what? This will be just x squared minus 2 minus x squared plus x, and present it that way, divided by, so 1 times this you still get what? The square root of x squared minus 2 plus root x squared plus x. That is it. Then you simplify the numerator. And the numerator, you realize that this will be x squared minus x squared, which is giving us 0. So meaning that in the numerator you'll be left with what? The limit as x approaches infinity of negative 2 minus x. Why minus? Because if you open the brackets here, this positive will be affected. Meaning that now it will be negative x. And the denominator multiplied by 1, so it does not change, it remains the it is. Then plus root x squared plus x. Now the question is, what happens at limits at infinity? We divide both the numerator and the denominator by the highest power of x in the denominator. When you look at the denominator, the highest power is not 2. It is 1, because this 2 is affected by this square root. Just like the previous case, it is affected by this square root. So meaning that we have to divide both the numerator and the denominator by x. So this will be the same as what? The limit as x approaches infinity of the numerator, which is negative 2 minus x. This is multiplied by 1 over x, because we are dividing by 1 over by x. It is the same as times 1 over x divided by the square root of x squared minus 2 plus the square root of x squared plus x. All is multiplied by 1 over x. Then from there we can open the brackets. For the numerator it will be now as follows. This times this you get negative 2 over x. This times this you get minus 1. It will be x over x, which is 1, which is divided by this multiplies this term and again multiplies this term. So meaning that we shall have 1 over x multiplied by root x squared minus 2 plus 1 over x multiplied by root x squared plus x. So once again we have to bring this under the root sign, so that you can be able to simplify it further. For you to be able to bring this under the root sign, you have to square it. You have to square it. The same applies to this. Now this will imply that this will be equal to the limit as x approaches infinity of negative 2 over x minus 1 divided by the square root of 1 over x squared. Because 1 over x squared, you get 1 over x squared into x squared minus 2 plus this you bring under the root sign by just squaring it and multiplying by this value. So this will be the square root of 1 over x squared into x squared plus x. And extend this line here. Then we can simplify further. So the simplified form of this denominator will be the same as what? So this will be negative 2 over x minus 1 divided by, so multiply this times this, it will give us x squared over x squared, which is just 1. So this will be the square root of 1. This times this, it is going to give us negative 2 divided by x squared. Then you move to the next term. This times this, you get the square root of 1. This times this, you get plus 1 over x. Because you know that 1 over x squared times x, you get x over x squared, which is 1 over x. which by direct substitution, it will be the same as what? Negative 2 over infinity. We are replacing the value of x with infinity. You minus 1 over the square root of 1 minus 2 over infinity. Because you know that infinity squared, you get infinity. Plus the square root of 1 plus 1 over infinity. You need to extend this a little bit. So, but we know that any number that is divided by infinity, you get a 0. Now this will be equal to 0 minus 1 divided by the square root of 1 minus 0 plus the square root of 1 plus 0, which is going to give us what? Negative 1 divided by the square root of 1 plus the square root of 1. But you know that the square root of 1 is equals 1. So this will be just the same as what? Negative 1 divided by 1 plus 1, which is equals negative 1 over 2. Now this will be our limit for this particular function here as x approaches infinity. The next example is evaluate the limit of this particular function as x approaches 0. So once again, you notice now in this case, unlike the others, the stars are in the denominator. So the solution of it will be the limit as x approaches 0 of x divided by the square root of 2 plus x minus root 2 minus x. So meaning that we multiply the denominator by the conjugate of this value here, or the denominator. So we change this sign from negative to positive. The conjugate of it will be root 2 plus x plus root 2 minus x. So what we do to the denominator, we also do it to the numerator, which is 2 plus x plus root 2 minus x, which is going to give us what? The limit as x approaches 0 of x into root 2 plus x plus root 2 minus x, which is divided by, so whenever you multiply this times this, it should give us what? 2 plus x minus brackets 2 minus x. So we apply this property a plus b multiplied by a minus b, which is supposed to give us what? A squared minus b squared. And with that one, it means that this will be 2x or 2 plus x minus 2x or 2 minus x. So we try to simplify the denominator. This will be the limit as x approaches 0 of x root 2x 2 plus x. Because if you multiply these times this, you get what? Maybe you can just leave it the 80 so that you can be able to see that you'll be able to get a common factor between the numerator and the denominator. So this will be x multiplied by root 2 plus x plus root 2 minus x. You divide this by, so if you open the brackets, this will be 2 minus 2, which is 0, and this will be x minus x, which is 2x. Because we know that x plus x, you get 2x. So meaning that this x will cancel with the x that we add there on the top. So this x approaches 0. So this will give us what? The limit as x approaches 0 of now root 2 plus x plus root 2 minus x. That way, which is divided by 2. Which is divided by 2. This is going to give us what? By direct substitution, It means that whenever you have x, you're going to replace them with 0. So these would be root 2 plus 0 plus the square root of 2 minus 0. All these divided by 2. So which is going to give us what? Root 2, because we know that 2 plus 0 you get a 0, or 2. Plus 2 minus 0 you get 2 divided by 2. So but what is root 2 plus root 2? This is going to give us 2 root 2, which is divided by 2. And you notice here there is a common factor which is 2, so you can be able to cancel it out. At long last you're left with root 2. So this means that the limit of this particular function as x approaches 0, it is equals to root 2. So the next example, you are told to evaluate the limit as x approaches 0 of this particular function here. So what happens here is the limit as x approaches 0 of root 1 plus x minus 1 divided by x. So you notice here that the third is in the numerator. So meaning that you have to rationalize by multiplying both the numerator and the denominator by the conjugate. The conjugate in this case it will be 1 plus x plus 1. And what you do to the numerator, you also do to the denominator. That is root 1 plus x plus 1. So which is going to give us what? The limit as x approaches 0 of, now when you multiply this by its conjugate, it's going to give us 1 plus x minus 1, because you know that 1 squared you still get a 1, over x, which is multiplied by root 1 plus x plus 1, that way. So should you simplify the numerator by grouping the like terms together, you notice that 1 minus 1 is equal 0. Now this will give us the limit as x approaches 0 of x divided by x multiplied by root 1 plus x plus 1. So whereby you notice that here there is a common factor between the numerator and the denominator, that is x. Now our function will be the limit as x approaches 0 of 1 over root 1 plus x plus 1, which is equals to, by direct substitution, it means that whenever you have x, you replace it with 0. This will be 1 divided by the square root of 1 plus 0 plus 1, which is equals to 1 over root 1 plus 1. What is the square root of 1? It is equals to 1. So meaning that this would be 1 over 1 plus 1, which is equals 1 over 2. 1 over 2, it is our limit of this function as x approaches 0.